All right, so now we are going to deal with more quantitative. So quantitative data, very often we don't want to put a category for each number, like each measure we got, because then we'll see if any of the measures had some frequency, but otherwise it's too minuscule. It's hard to get a general sense for what's going on. So what we do is I would say zoom out from the data, which means when I zoom out now, two things that were next to each other, it's hard to tell them apart. And that's what we're going to do. We're going to merge a couple of measures into one bin. The bin is going to represent just a certain range of values. And then the next bin will represent the next range of values. But one of the catches is bins must be of equal size. So if I decide it's going to be a bin that covers 5 numbers, every bin has to cover 5 numbers. Now, when we can bin the data like this, our bar graph actually takes on a special meaning because now the width can be associated with a range of values, and then we can actually like configure or calculate the area to figure out some meaning. It's really interesting, I think, but I'm weird. All right, so must be the same size. This can get a little weird with grades because, so here, like I look, the lowest grade is 72. These are actually in order, yay. And the highest grade is 98. So I could just take those as my lows and my highs, but these are exam scores. So I know the theoretical highest exam score would be a 100. And then it could certainly go lower than 72. So one way we could do it would be to just clump it in our normal letter grades, like 70 to 79, 80 to 89. But then it would be 90 to 99 would follow the trend. And then where does 100 go? So strange as it sounds, we'll actually start, a lot of times we'll go down. But in this case, since we don't have a 100, we can kind of ignore it. But what I listed was only 3 bins. That's a little too zoomed out. You want 5 is the good number. Like we could do 6, 4, really 5 or 6 would be better. Because you want to be able to get a feel for where's the high, and just knowing, the high is in the C's. Well, is it high C's or low C's? Were the low B's kind of close to that? So we're going to go with like low C's, high C's, but I'm going to write the numbers. All right. So we're going to start with 70 and we're going to run that to 74. Then 75 would be the next number. And we can do this because these are all whole numbers. If there were decimals in there, like if 74.5 was a possible score, then I'd write 74.9 and 75 for the next one. All right, so 75 up to 79. Then 80 up to 84. 85 up to 89. 90 up to 94. 95 up to 99. So in a full-blown statistics class, they love this question, but they also love to throw the 100 in there because then you have to figure out what to do with it. It's annoying. All right, now we're just going to count. And since these are in order, I see 3 in my first, 72, 72, 74. Then 1, 2, 3, 4, 5, 6 in the next bin. Now we start at 80s. I see 3. So when we say to 84, we're including 84 in that. Just like before, the 79 got included in that count. So it's not just the stuff in between, it includes the numbers we're writing unless we write it in a special way. There is a way to notate that, and certainly you can think of a graph that way. And it makes sense if you have like decimal values. All right, and then the 90 to 94, there's 2. And then the 98 is the only one in that bin. There we go. Now, there's our frequency table. I like to know my total, though. It just bothers me to not know. So 3 and 6 is 9, and 6 is 15, 16, 17, 18 scores. So we could calculate the relative frequency by doing the division. It's kind of ugly with 18, though. We're going to get repeating decimals. And we could also do the cumulative. All right, so with our data here, and note, I scribbled off a thing there. The line is there, but the data set that went with the line is MIA. So we'll just ignore it and continue on. We'll still do a percent. Well, we actually already did a percentage on the first table. Okay. Oh, we are actually going to construct the pie chart here. So now we want the relative frequency. All right, 3 over 18 equals ugly. So I don't want to calculate 0.1% on a graph. So I'm just going to round this to 17%. Now my 6 out of 18 is actually 1/3, or the 0.33. So this will be 33%. And now another 3 is going to be another 17. And this is where it can get a little weird, because it's like, well, you had a little extra that you rounded up, and now you're doing it again and again. It is possible with where you choose to round to get a sum on the percentages that is actually more than 100. Like, I've seen research articles in fancy magazines where they have a little star that says, note, due to rounding, these total to more than 100. And that's totally fine. As long as you notate it. Yep, people are just like, oh, okay. All right, 2 out of 18 is only going to be 11%. And 1 out of 18 is going to be very small. So 2 places is 5.5. So we're going to call that 6%. All right. So I know not the easiest to read, but we have our percentages. Now in a sec, we're going to come back and we're going to calculate what the degrees would be for each of those, which is going to give us the rough like size of the circle, which I know like 17% does, but knowing is that going to be 45 or 50? Like, I don't know off the top of my head, but it's degrees out of a full circle, and a full circle measures 360 degrees. So we would take 17% of 360. Yeah, no. And that is the same as taking the decimal, 0.17 times 360. And so that is the degree measure. So it's about 61 degrees. So we can say about 60 degrees. Drawing a pie chart by hand is ugly. It can be done. Like, this is how you would do it. And then you hopefully have a tool where you can, like a protractor, where you have your starting line and then you count 61.2 degrees and put a mark and then draw a straight line and there's your first wedge. It's really tedious to do by hand, and nobody does it by hand anymore. But asking you to calculate what would the number of degrees be is fair. Now, this is pulling in some of the geometry that we haven't gone over yet, which is also the order the book put it in. So 33% of 360, that is 1/3. So that is 120 degrees. Here, I'm just going to short that to deg. All right. Our 17% is again going to be that 61.2. And that is actually 1/6 of the circle, roughly. The 60 degrees would be 1/6. And then the 120 degrees is 2/6. So we've actually accounted for 4/6 here, which is actually more than that. Because there's 3/6 and 2 more. This is 5/6 of the data. So then we just have to split the last sixth, and it's going to be a 2-to-1 ratio. So our 11% or 2/18 of 360, because you could go back to the fraction. And the fraction would actually work out precisely. Yep, 18 actually goes into 360 nicely. In fact, it goes in 20 times. So this is 2 times 20. These that were 3 would be 3 times 20. So those are really 60 degrees. And then our 1 out of 18 is going to be 20 degrees. And 40 degrees. Now, if you run a calculation like this where you rounded and then you used your rounded number, I will follow through your calculations as long as you turn in your work. I will dig through and see and figure out why you made the mistake you made if I can, if you showed me enough. And if it's something like this where, you know, you rounded earlier than maybe you should have, it's hard to tell when to round and when not to. So yeah, I will try my hardest to give you credit for doing the math correctly, even if something like this carried through. I'm not going to ask you guys to draw a pie chart by hand. Calculate the degrees, fair game. Actually do the doodle, no. All right, so first things first, we need to construct the bar graph. Now, because we have binned data, the bar graph actually takes on special meaning, provided some certain rules are followed. So our bins are all the same size. And we have to draw them so that each of the columns is the same width because they represent the same range of numbers. Like not the same exact numbers, but there's 5 numbers in each range. So as long as we do that, then we create this fancy thing called a histogram. But really, it is just a fancy bar graph. Then time series graphs are a graph where time is running along the bottom, and then you have some sort of data being shown. So pie charts, not time series, because there's no bottom to run along. All right. So for just raw frequency, bar graphs, or if the data is binnable, histogram is the way to go. And I don't know if we're going to make that distinction really big later on. I don't think I saw histogram in your ALEKS homework, at least. I'm just putting it out there because sometimes people will use this word, and I want you to know what this word means as opposed to other words. All right, so to do this, we need to assign the labels. And this is where it can get kind of annoying. No, I wanted. All right. Ooh. All right, I'm just going to go with 3 because I have no idea. And it is very much just picking an arbitrary width and sticking with it. So there's 1, 2, 3, 4, 5, 6, and we have 6 bins. And then I am making, I like to have actual cross lines for my tick marks. So I'm moving the actual axis in one. Technically I shouldn't, but my graph will do it my way. Now, our frequency actually only goes up to 6. So as long as our tick marks are evenly spaced, we could go every other one if we want here. It would look a little prettier because it would fill the space accordingly, which is something you should try to do when you present a graph. You don't want to make it 0 to 100 for the frequency, and then all your bars are squashed on the bottom of the axes and they're so small you can't even compare them. That is not a good graph. It may be accurate, but it doesn't present the information in a meaningful format. So these are some of the more like common sense things that you need to think about here. And that's the bigger question is, which way should we represent this data? Does it make more sense to do a bar graph, or does it make more sense to do a pie chart? Or would the pie chart have no meaning whatsoever? And it just depends, but we can do those for any type of data. And categorical data, sometimes the pie chart makes more sense because I want to know, which color got named most. I could see that with a bar graph. I can really see it with the frequency table, but I could also see it with the pie chart. All right, so let's see if we can do this. 1, 2, 3, tick, tick, 4, tick, tick, 5, tick, tick, 6. Okay. All right, now we get to see if we can actually draw the things. So our first bin is supposed to be 3 high. So from the baseline, 1, 2, 3. All right, no. So there is our first bin. Now at the bottom here, we should put the labels. I'm gonna see if I can type it. So our first one was 70 to 74. And again, the nice thing is if you do this in Excel, it'll do the labels for you too. Like as long as you know how to set it in, boom, it is beautiful. And believe me, people older than me don't know how quick and nice it is and how to make it do all the fancy bells and whistles. And if you can do that, it makes a big difference to your boss. Just remember to get your credit for doing the thing. So it may not seem like a lot of work to you, but you knew how to do it. For an older person, it might take a lot more searching and playing around to find the right settings and get it to do the thing. So don't shortchange yourself if you do something quickly. All right. So we have our lovely bin labels. And then my first one, notice that I made it the full width. So I'm not doing like a little skinny bar and then I'm going to leave space. Histograms actually butt up right next to each other. Now, if we were just going to do this as a point and make this into a line graph instead of a bar chart, we would put the point in the middle of our bin width, which would look a little weird with 3 wide bins. But it does look like I could have made 4 wide bins and then that would have made sense. But you can do it on the half mark. It just looks a little weird, but it is correct. All right, then the 75 to 79 gets our 6. 6. And those of y'all not having to draw on the computer screen will do a much better job. All right, then the 80 to 84 are going to get 3. And the 85 to 89 will get, that was horrible. We'll also get 3. And then we have 2 and 1. Now, the nice thing about a computer doing it is the computer will automatically gauge what it thinks the range on the y-axis should be. If you want it different than that, you actually have to fight kind of hard with it to get it done. But it can be done. And if you need really super fancy statistics, there's actually big software packages that'll do the things. but this is how we would do it by hand. So the only catch is, since our data is binned, we make our columns all the same width and mark it up to the frequency and make that fill the whole bin, and then butt them each up next to each other. So we can see here there's definitely more in the 70 to 79 range than there is in the upper ranges. So we got a spike and then it trails off, which is, almost a bell curve. It's a little skewed, but we don't have the data for the 60s and 50s, so. All right, now a pie chart. Ugh. We're gonna cheat. Like, we calculated the degrees. That is all I would want you guys to do by hand. I don't want you to do this. Ugh. All right. So I can still see both. I was playing around earlier, so these are the wrong frequencies. And these are the wrong bin labels. Let's see if I can do the fancy. Ooh, I think I can. No, not that much. Fine, that much. I will take it. All right, so I have my 70 to 74 as labels, and then I have my frequency. All right, so I'm just going to highlight those two, my labels and my frequency. And then I was already on insert from earlier, and you can see there's different chart pictures up here. So there's like hierarchy, it does all sorts of craziness. Generally, though, these first three are like the ones you're going to want. See, this one says a statistic chart. So we can do a histogram and shows the distribution of the data grouped into bins. I believe if you type in the data, like in a whole bunch of entries and cells, you can make it do the histogram like this. That did not work the way it was supposed to. Let's see if the pie chart will work. No, because it's not reading the data correctly. All right. I'm going to pause. I didn't pause the video, I paused the share. Poof, magic. And you got to hear me talking to myself. Oh, well. So now it's all typed in nice. Now we should be able to highlight, and there we go. So there's a bunch of settings we could play with here. Let me make this a little bigger. Like, you can make the colors not so ill. There we go, that looks a little better. And you'll notice here at the bottom that they have the labels down here. There is a way to make them do labels around instead. Yeah, data call out like that. And then you can take the legend off at the bottom and it makes it a little bigger, put it on. Chart title, you just double click on that and then you can make it whatever you want. A lot of teachers, and especially if you're going to put a chart in for another class, it needs a title. Like that's one of the big like, ooh, where's your title? Like legit, even in grad classes, they're like, you didn't put a title. It was my homework. I should have written 18 down on top. I'm sorry. They actually want words too. Like you can't just put 18. So this would be like a distribution of exam scores. Sure. I should make it title capitalization, but there we did a thing. And I could also take this and copy paste it into a Word document and make it look all fancy there. I could also insert a table in Word, put this in, and then I can use the same insert chart and it'll let me work that. Cool. All right, let's see. So we couldn't get it to do a histogram, which is not entirely a surprise actually, but there's just a rough bar graph. It is not a histogram, even though the bins are all the same width, they're not butting up next to each other. So seeing a bar graph like this implies that there could be something in between the bins. Like that's what the spaces are for. That the possibility exists. It doesn't mean there has to be, but if these were like brands of jeans, then I would want the spaces because it's not a, well, you know, the first few, obviously Levi butts right into Hanes. I don't know. I'm not a fashion person. I'm wearing a nightshirt. Deal. And the pie chart is actually still back there. It just spawns on top of. And again, there's plenty of settings you can play around with, but for pie charts, this is 110% what I would expect you to do. Not do it by hand. It is ugly by hand, but you can see the blue, the gray, and the orange wedges here look like a sixth. And then this red wedge does look like a third because it is. So those sizes I was talking about when we were doing the degrees are what we see here. So we were thinking the right things. All right, let's flip it back. Okay. So I will pause it and then do the one more example in a third video.